Okay, some additional sample problems. Red marker's not showing up too well, so no, it's not bad. So, same sort of starting problem as the first problem in your pre-lesson, but there's always a little curveball, a little change. Look at it. Now we got a cubic root problem, and we remember that the parent function of the cubic root problem was flatter, and it kind of goes like this. Okay? Showed that in the pre-lesson. Take a look if that doesn't make sense. But now they're throwing this little 2 at us and asking us, what does that 2 do? Well, because this is a cubic root problem, we have to think of our perfect cubic roots and pick numbers that just work. So again, like I said, the book picks out like they just strong-willed. They're going to pick 4. I don't think that's necessary. If you can get 2 or 3, you'll get the idea of what's going on. So I'm asking myself, all right, is there a nice, easy choice for x without introducing decimals or fractions? So, is it easy to go 2 times something is 1? Well, x would be a half, but I'm not going to worry about that. Or we could. I mean, maybe you want to start there. So if x is a half, and I say, all right, 2 times 1/2 is 1. The cubic root of 1 is 1. I guess that wasn't that bad. Let's go into this one. Is there an easy value for x that makes this 8? And the answer is yes. That would be 4. But now let's do the math. 2 times 4 is 8. The cubic root of 8 is 2. Is there an easy number where I can say 2 times something is 27? Nah, I'll skip that one. Is there 2 times something equals 64? Yes, 32. Now if I put it in there, 32 times 2 is 64. What is the cubic root of 64? Well, that's 4. And I think that's enough. So, also, I always forget 0, 0. Anyways, 0, 0, let's plot these. If we go out 1/2, we go all the way up to 1. 4, 2, 1, 2, 3, 4. Would be 2 right here. So as you can see, it's kind of climbing a little bit faster. And now, interestingly, there are negatives that we can pick for our x, so x and y. So what would be an easy negative to pick? Well, might have to use our noggins a little bit, but isn't there a -8 that works? So 2 times what is -8? Well, that'd be -4. Now, if I popped it in there, 2 times -4 is -8. The cubic root of -8 is -2. And so I plot that 1 point. 1, 2, 3, 4. 1, 2. So it'd be like that. As you can see, I'll make my final answer red. It'd be like that. Kind of cool looking. Do they ask for domain and everything? Yes. So, what is the domain? I'm just going to do the domain of the red one. Well, how far left does it go? -infinity. It just keeps going left. How far right? +infinity. How about range? Well, it doesn't go up fast, and it doesn't go down fast. But if it does that forever and ever, it's definitely going to go down to -infinity, and it's going to go up to +infinity. Now let's focus on this red graph here. If I put my guy right here, and he has to move left to right, is he going to go uphill or downhill? He's going up. So this is considered an increasing function. Again, you're getting better at that language, I hope, okay? Next example coming up. Here's a translation problem. They say if f of x equals the square root of x, which is just saying, hey, if this is the parent function, then what happens? Which, by the way, they shouldn't have to remind you of that. You should be able to just look at this and go, aha, it's piggybacking y equals f of x. But sometimes they're nice, and they just kind of help you. Well, we know what this looks like. It looks a little bit like that. So what does this do? This is going to vertical stretch by a factor of 3. I might have gone up a little too fast, because remember, that could be an 8, a 12, a 20. You're trying to show that you understand. So that's a vertical stretch by 3. This is going to move it left 1 unit, so 1 unit. I'm just going to try to duplicate it. So now we're moving on, so erase it. And then we're going to move that guy down 2. 1, 2. Erase it, and then try to, I forgot what it looked like, but it's going to go like this, and like that. So that's where my final answer would be. That point right there is incredibly significant. Remember, we went left 1, down 2. So that's -1, -2. It's helpful because we're going to ask about the domain and the range of each. But I'm just going to talk about this final one. So how far left does it go? -1. And it goes on to the right forever. How low does it go? -2. How high does it go? It goes up forever. Increasing or decreasing? Well, our little guy would be going up, so it's increasing. You visual learners, we all are visual learners, but sometimes people just don't like to be number crunching all the time, just like to look at stuff and make sense of it. So they're just telling you that this is the parent function, y equals the square root of x, and they're like, okay, smarty pants, find the equation of that one, or the function. Well, this one has already used the name f of x, so we're going to use g of x, and now we got to look at some clues. Now, if you look at these example problems in your book, they've got these nice, they got the xy axis, it's nice and bold, and then they've got all these beautiful little markings, and then you can see where the graph goes through these points. I don't have that luxury, and I'm not going to take the time to do it. I'm just going to try to explain this to you. I guess I just did it, but here's the deal. Notice this is 1, 1, and we know that's true if we were to make a little graph. 1 for x, square root of 1 is 1. So that proves that it fits in that function. Now what about this? Well, there's a little clue that I want you to see. That's -2, and this is -3. I purposely put that little dot halfway up because this moved right 1, up 1. This moved right 1, up a half. That's what I want to talk to you guys about. So that means there needs to be a 1/2 because it's vertically compressed. I don't know if you can tell. It's kind of a subtle. But you need to kind of get a magnifying glass and look at that. And then also it's moved to the right 1. So that means I'm going to go x minus 1 underneath the square root. And then down 3. That's where that spot is. So it moved that spot, right 1, down 3. So that's letter D. And there's the equation from the visual. Math trickery coming up. Something you have to be on the hunt for. It doesn't happen all the time, but it happens some of the time. And this is unique. So it's giving you this weird looking equation. There is no vertical stretch or compression. But something's weird about this. It says graph it and explain transformations. Yes, you could type this into decimals and it can do it for you, but that's not the goal at all. We're looking at this and we're asking ourselves, well, how could we do that? I mean, what's the trick here? Well, if you look at this, I have a 4 and a 16. So now you have to be on the hunt for common factors. Watch this now. I'm just going to make it look different. I'm going to factor a 4 out, and I'm left with x plus 4. Which, guess what? That's the same thing as the square root of 4 times the square root of x plus 4. I'm not forgetting about this. I don't care about it right now. Which is 2 times the square root of x plus 4. And here comes the plus 7. And now I've made my life so much easier. So this is a handmade problem for you to recognize that you can factor that stuff, especially if you factor something out and that something is a perfect square root, because then it's just going to pop out as your A. So an extra step to this stuff. So what happens? Well, it says graph it. Parent function looks like this. So we're going to double it, so it's going to go up faster. It's going to move left 4. And then it's going to move up 7. There's the graph. Explain it? Well, we just did. Vertical, I said originally like, hey, there's no vertical stretch or compression, and all of a sudden there was, because of factor. So vertical stretch 2, left 4, up 7. That's it, you guys. So good luck on your homework. Look out for those tricks.